Hello, everyone. My name is Thor Kallestad. I am the co-founder and CEO of the Myno Carbon Corporation. Welcome to our YouTube channel. This is our webcast, The Shift, where we talk with innovators doing really creative new work in the field of biochar. And today I am extremely excited to be joined by Dr. Jim Ippolito, the professor of soil science at Ohio State University. I've been really looking forward to the conversation, Jim, because I think some of your professional journey might really parallel some of our corporate journey that we've gone on since founding Myno about 4 years ago. So welcome. It's nice to have you here today.
Thanks for having me, Thor.
All right, great. Well, I was wondering, to kick us off, Jim, if you could tell us a little bit about your sort of entry into biochar, where you found out about it, a little bit just kind of the high level of your journey on it. Before going, I would quickly say that we started out looking at agriculture markets as the best use of the biochar, and we couldn't quite crack that nut economically. And we since have pivoted to remediation as our main area of focus over our journey and starting to get much more traction on just with data sets and at prices that work. And it looks like a much more scalable market opportunity for us. So with that as context, I'd love to hear a little bit sort of about your journey along the your entry into biochar.
Yeah, that sounds like a good lead into our webinar here. And so, Thor, it's interesting that um, your perspective and my perspective are very similar. And so let me tell you how I got started in biochar. And I just so happened to be at the right place at the right time in the mid 2000s. I had just started a new job with the U.S. Department of Agriculture's research branch, the Agricultural Research Service. And I was approached by, I think, my research leader at the time, my boss, asking me, because he knew my background, asking me, would I be interested in working in and with biochar on a project across the country, across the United States. And so, yeah, I knew nothing about biochar at the time, and I had to do some digging. And it sounded very exciting, especially working with six or seven other locations across the United States from the East to West Coast on the same subject. And I usually refer to this as catching a wave. I caught this biochar research wave in the mid 2000s, and it was a wave that was in agriculture, much like where minocarbon first began. I also began focusing biochar research in agriculture. And over time, I've come to the same conclusion that your company has come to, that it's a tough nut to crack in terms of getting biochar in large scale production agriculture settings. So you need to pivot. And so anyway, that's where I started, and I still work in biochar today, even 20 years later.
Yeah, that's great. I really like the concept of these waves that you mentioned, is because I think we're starting to see a bit of one is when we got going, a bunch of us all came out of the oil field, and if not the oil field, various different corporate backgrounds where people had been in large companies and managed P&Ls, and we really wanted to have a scalable climate business is what we really wanted to build with Myno. Of how do you profitably do something about climate change? And we felt biochar, for all the reasons you're very well aware of, was the right scalable approach to do it. That you made this product that had this commercial application that could be worth money to help out get an IRR where investors can make money and raise investment and scale and remove tons and tons of carbon. Definitely the vision on it. Where we ran into, again, it was the ag challenges of those sort of longer term off takes at price and volume for financing a facility just weren't there in the market. But to the wave thing, one of the things we've seen is PFAS is clearly on everybody's radar. These forever chemicals now. If we've seen, there's tons of wave momentum around that. So we think as on our remediation applications, love to hear your thoughts on this. Is we're thinking about it in three kind of areas. There's that PFAS wave, a little harder to technically get the specs needed for a variety of these compounds. And then there's hydrocarbons and metals. Mine site reclamation are really the other ones. Hydrocarbons and metals look to be a little bit quicker and more straightforward, but PFAS holds just tremendous potential. I was curious, with the wave analogy, any thoughts on those sort of three, or also things, other ways we should be thinking about these markets and the various opportunities out there, in addition to just those kind of three silos that we're seeing right now.
Yeah. How much time do we have?
Yeah, it's a great question. Yeah, no, we spent years trying to crack this thing here.
Yeah.
So
So it's interesting that you bring up these 3 points because I've worked in both of those, or all three of these locations or points within the research realm of biochar, and that's because in the ag sector, several years into working with biochar in the the mid to late 2000s, this group that I was working with quickly realized that it it would be nearly impossible to break into large scale production agriculture with biochar just because you take a simple pencil to the paper approach in terms of economics, and a farmer can't afford biochar. Even if you're applying 1 or 2% by weight, which is 10 or 20 tons per acre, they just can't afford it at the cost. So you need to look for these other markets, and I've looked at those other markets. I still work in the space of mineland reclamation with respect to heavy metals in biochar. I love working in that space because it's fun and it's challenging. The target is to reduce metal bioavailability by either sorption or precipitation of metals via the use of biochar. And not all biochars are created equal. So, we do some simple screening to identify which biochars may work the best in terms of sorbing metals and then not re-releasing metals back into the environment. This is some recent work that we just published. Very simple approach. Take you a couple weeks to get an answer, which isn't too bad. I haven't worked with PAHs directly, but I've worked in halogens. So, another, I guess, organic contaminant, and I've done some work with halogen sorption and remediation on a small scale within soils, where it looks like these biochars that we were working with can hold on to these halogens and keep them in place so microorganisms can attack them and degrade them, which is an interesting concept. I guess the concept would be similar to PAHs. And then, yeah, the PFAS issue is a monster. And I was trying to get out of biochar research about 3 or 4 years ago, and
good
biochar
luck.
did not want me to get out of working
Yeah.
with it. And I was approached now 2 times over the last several years to focus efforts via the use of biochars for sorbing, sequestering, and reducing basically bioavailability of PFAS, where PFAS is in the environment. Um, that's a tough nut to crack because there's so many different types of PFAS, and the concentrations in the environment are typically low compared to cations or metals. So I think the jury's still out if biochar will work in, say, a soil environment, but it sure looks like it works in a water environment for removing PFAS.
Okay. Okay. Interesting. As we've shifted focus into the remediation space, one of the things that we've consistently run into is that people are willing to pay high prices for this stuff. Price has not been the challenge, and there's big quantity deals out there to be had. What really has been the challenge was just getting specifications and repeatability around, what is the biochars, as we've learned to refer to it as, that you'll be delivering for a customer, and getting them comfortable that what they get from you today that works today is going to be the same thing 5 years from now. So we've taken that sort of market feedback on board, and that's kind of rolled right into our engineering thoughts about this for the facility design. Is rather than some, yes, we want to be as low cost as we can on the facility and the engineering side, but rather than a facility that does just one thing, making a biochar for ag, we really want to have some flexibility in that facility to be able to have different modifications on the biochars for different contaminant specific reasons, whatever those might be that the market demands from us. And so, yeah, I was curious, I don't know, your thoughts or advice around that sort of thinking about it. We kind of feel that's the step to go through to scale this, to show that these different biochars can be made, successfully used in the field.
Yeah, you bring up some really good points. And obviously, you've seen this, I've seen this. where somebody may make a biochar and it has one set of properties one day, and the next day it has a different set of properties. And so, not that you've changed anything during pyrolysis, but something obviously changed. Whatever it is, maybe it's a feedstock, it's changed slightly, what have you. But I think about this often because I'm a scientist, and I work in a laboratory among other places. I do a lot of work outside as well, but I've worked in a laboratory almost my whole life, and so I think about, what could you do if you didn't know what product you were creating from a day to day, one day to the next, and so you'd want somebody to test that product for repeatability. I'm not suggesting that you set up a laboratory, but it would be ideal if somebody had a laboratory where they could take their product to maybe once a month just to have it tested to be sure that what you're producing will do what you say it's going to do, if that's metal sorption or PFAS sorption or what have you.
Yeah, no, that's it's great to hear because we're just seeing more as we've shifted our focus into this. It is pretty consistent. A lot of these large corporations say, yep, we get it. We would buy that. We'll pay a bit for it. It matters to us. The sustainability part of this, the sequestering carbon part of this, those things all deeply resonate still with a lot of these customers. It's getting that repeatability, the performance part of it really buttoned up. That with that, then I think you can really unlock this industry, and remediation starts to be the engine that really pulls it through. Our thought on that also is that if you go through that step, and we feel pretty, we're feeling reasonably confident about our ability to successfully do it here now that we've identified where people will pay price for volume. That was really a key thing that we didn't have when we were looking at ag. But as that does come together and we can start getting into some of these kind of lower value markets but still big impact markets, ag and such, I was curious if you could talk a little bit about your thoughts about where might it be most valuable, have the highest value case and climate impact in the soil sciences and in the agribusiness communities.
Where can you get the best bang for your buck? If you're an ag, probably the best bang for your buck in terms of biochar would be in some of those high cash crops. And then one thing that I'm starting to see this in the literature now, but it has not been in the literature in the past, and that's repeated applications of biochar to parcels of land. All I've seen for the last 20 years are the same studies repeated over and over and over again, where somebody's applying biochar at maybe different rates to corn, and they're looking at a response. Well, I mean, that was done 20 years ago. So, but what you don't see in the literature is repeatability or reapplicability. Oftentimes you don't. So that's starting to come out. And then I start thinking about, okay, if you have high cash crop where this might be beneficial, and it might be beneficial to apply biochars repeatedly over time. And I can't tell you if that's good or bad, but the idea or the concept is, from an economic standpoint, much more sound than applying biochar to corn in the Corn Belt, for example. So looking at crops that cost quite a bit of money where you might see beneficial use of biochar.
Okay, interesting. That's good. It kind of tracks with the one area I think if there was, the first sort of application use to really crack open for ag, our thought is that it's probably in the liquid fertilizer markets. Just incidentally, up here in Washington State, where we're based, I think it's something like 80% of the fertilizer markets is liquid conveyance out here. And our thought is that it's similar to what you had just described, that it's just a little bit of very finely micronized biochar that's going into these liquid systems along with other sorts of fertilizers, and that's just something that you consistently do.
Right.
So, yeah, and now we're thinking about those liquid systems as possibly precision agriculture for one of the buzzwords around it.
The liquid systems, are you talking about liquids like drip systems?
Yeah.
Yeah. So this is an interesting idea in ag, and I've tossed this idea around with other people where you would place, and it wouldn't have to be liquid, but you could do liquid. The thought process for what we've been, kicking the idea around is to place biochar if you're going to place biochar in agriculture, place it in a trench so it's concentrated, and it's concentrated closer to wherever the plant is growing, be it corn, or if you're going to do corn, or high cash crops. Something I tried to pursue years ago in eastern Washington was putting down trenches of biochar in new apple orchards. And we never received the funding to do this, but if you could apply, I don't know, if you apply 5 tons per acre over a whole acre broadcast in corn, or if you concentrated 5 tons per acre, but in a band, you actually might see a response, and maybe a positive response and a longer response over time. And it's simply because you're not spreading the biochar around, and so you're reducing its effectiveness. You would see somewhat of a similar response if you applied biochar over and over again through a drip. Um, it's just a matter of figuring out what the application rate would be through the drip line.
Yeah, yeah, interesting. That's what we've thought. Okay, I think it's kind of a structurally similar sort of approach to introducing it into the cropping systems.
Well, yeah, and if you could get that biochar into the soil, the biochar loves sorbing all sorts of things, especially, I should say this, but it depends on the biochar, but more often than not, biochars love sorbing these positively charged ions. So most of the nutrients, not all of the nutrients that plants need, but some of the nutrients, they're positively charged. And so if you could hold those charges in place, so eventually the plant can see them instead of not seeing them, for lack of a better term, biochar could do that. And so, yeah, maybe applying biochar through drip might not be a bad idea.
It was our thought also that it's kind of, ease of application. You're really not asking the grower to do something more than put stuff in the tank, which they're already doing for those, drip systems. That it's maybe, the nutrient use efficiency story that you spend a little bit less on your fertilizers, but add some of this biochar, and then you start to slowly build up the biome and the carbon, and it's just a way to, we thought, more economically get it to the right point, and start introducing it to the soils over time. Yeah, it's been one of our findings, Jim, in the remediation space. It's really that repeatability and that consistency of specifications and performance is one of the big things that's needed to get financeable offtake and really scale the industry. One of the thoughts that I had about that is how best to use some of the academic and test information on this to help with that repeatability and consistency question for large potential off-takers that would like to use modified biochars in remediation applications. Just curious if you've got any thoughts on how they would best, engage with the larger academic world, how the two sides can work together there.
Yeah, that's a great question, Thor, because it sure seems there's a disconnect between industry and academia. In academia, and I've been in academia my whole career. A lot of academicians love to just tinker. We discover things and we tinker and we discover something else, and the word never reaches industry. And industry is doing something, and whatever industry is doing may not reach us in academia. So somehow bringing us together would be really great. And I've seen this happen a couple times, but it doesn't happen often enough. And so, I think about a lot of the meetings I've been to or conferences I've been to where we've brought both of these groups together, especially the U.S. Biochar Initiative conference that's held. It used to be held every other year. That conference would bring industry and science together essentially in one room. And I've made a lot of connections in industry because of that meeting, but not enough. One person and one industry contact is just not enough. We need to do more of that type of exercise.
Yeah, no, that's great. It makes me think of, Silicon Valley and some of the success that's come out of there, of the interactions by a lot of the tech companies with like Stanford and Berkeley and the universities down there. I could see there'd be that same sort of approach with, especially some of the large companies that have got these remediation obligations, to start looking at more innovative ways to do it with academia. So it'd be fun to be a part of bringing that together. Yeah, it's an interesting topic. If something like that were to occur, what do you think would be the big breakthrough areas to focus on? Of what we get from talking to some of these potential customers is why they're really interested in these biochar products is they all invariably want faster, cheaper, more effective remediation projects, their cleanups of the sites. I was just kind of curious if you had any sort of thoughts come to mind on what would be sort of the research topics and areas to focus on a collaboration like that with industry about how to get them faster, cheaper, more effective remediations of these contaminated sites.
You know, but that's a tough question to answer. You know what? Think about all the research that's been done in biochar. It's enormous. It's mind-boggling, actually. And I think about some of the breakthroughs, and some are fantastic, and some are just kind of okay. But like in mineland reclamation for heavy metal contamination, some of the work that, and I'm gonna top or toot my own horn. Some of the work that the group that I've worked in has done, I think has been really, really great work in terms of screening different biochars for metal sorption and prevention of metal desorption. We're using the same approach with PFAS currently. So PFAS sorption and prevention of desorption to take it to the next level. And I can tell you, so one of the roadblocks is taking it to the next level. I'm an applied scientist, and the people that I typically work with are applied scientists. I mean, yeah, we do a little bit of basic science, so we understand systems, but it's really applied science. But the disadvantage of doing this is not knowing people in industry well enough to take our applied science and scale it. And so I don't know how you make that connection. I guess that's why we're talking today. But somebody out here or out there in the world listening to this discussion, make the connection. If you don't connect with me, connect with somebody else in the biochar sciences field so we can start scaling some of our ideas up.
Oh, that's terrific. I'm going to take you up on that. I think I got some ideas around the mining space also that we can look at doing some of this together for some big, mine site remediation projects. So this is terrific. I really think that's where the magic happens. It's these interactions between it's academia, corporate buyers, and really entrepreneurship in the middle, kind of connecting those together. And I think there can be some really some innovative things happen here that help deliver that repeatability and performance that allow this industry to finally really scale.
I agree.
It's good stuff. Well, I really want to thank you for your time. Leave you with maybe one, parting question here is, over the next sort of maybe 5-year window of just kind of, an outlook on what it's going to take for biochar to really scale. No constraints on the question. What do you think really needs to happen? Is it policy? Is it corporations? Is it technical? Is it academia? What are really the missing things or one big one that could really help move all of this forward?
Yes, everything.
Yeah, there's not one. Yeah, it needs a
Yeah.
lot.
Well, definitely the connection between academia and industry that just needs to close. It's been so separated for the last 20 years. The gap needs to close. Um, there's so many things that we need to understand in order for biochar to really work well across landscapes. And one of the things I keep coming back to is, and maybe you've seen this with biochar, it has some static electricity. Have you ever noticed this? Sometimes if you pick it up, it goes everywhere you don't want it to go.
Yep.
And yeah, like about 10 years ago, one of my friends asked me, well, have you ever really thought about why? Like, why does it have this property? And so I can tell you, I started taking a deep dive down why it had that property. And I see in the literature that other people are actually going that route currently. It, it has static electricity, so it's negatively charged, actually. Not every biochar, but some biochars are more electronegative or negatively charged as compared to others. And that negative charge actually can do a lot of different things in the environment. And one of the items that it might be able to do if like industry could ever crack this or academia could ever crack this is to create a biochar that's so negatively charged that it can break the carbon fluorine bond in PFAS and do it abiotically, I think that would be really, really cool to crack in the near future, and then
Interesting.
advance it at industry scale.
Interesting. That is a that is a great insight on it, and I thank you for that because it really resonates with a project that we're working on that I look forward to following up with you very quickly here about maybe collaborating on that exact opportunity. So, with that, very grateful for your time and your insights on this, Jim. It's been great talking with you about this, and on behalf of all of our viewers, like to thank you and invite you back. This has been a great conversation and look forward to doing it again very soon with you.
Great. Thanks for having me, Thor.
All right. Excellent. Thank you, Jim.